All right, this is Mr. Ainsworth, and we're going to get into your homework here after lesson 5. When the base is less than 1, I taught less base equal to 1/2. Now your homework is equal to base equal to 1/3. Obviously, 1/3 is less than 1. The coefficient a here is greater than 0, so fix that in your notes. A is equal to 1. All right, that's important to know that it's positive. This means it's positive because if it's negative, something totally happens. This thing gets reflected below the x-axis here. So we're going to keep it positive. We're going to keep it 1 just to make things simple for this lesson. When you have a base that's less than 1, you have what's called a decreasing function. The y values decrease, or what's called an exponential decay function. All right, so get your graphing calculators off to the side, turn them on and get them ready, clear them out. Also, get a piece of paper on the side so you can do your arithmetic. I'm going to do mine here in the margin, but you guys might want to have a piece of paper on the side. And also remember, this is a video, so if I go too fast, which I probably do because I'm doing this by myself, go ahead and pause and play throughout the video and take it at your own pace. All right? So strap on your seatbelts. Here we go. So what we want to do is we want to pick an appropriate domain for the function here, and x, you can raise a base to any power you want, whether it's negative, 0, or positive. So because the domain is all reals, all right, we're going to pick some negatives, 0, and positives to get a good idea of what's going on with this function. So I'm going to pick a domain from -3 to 3. I'm going to substitute these values into the function right there, and we're going to check this out. Now, before I begin, 1 times 1/3 to the x power is just 1/3 to the x power, okay? This coefficient of 1 doesn't affect it any. And that's why I eliminated it right here, because when you multiply anything by 1, it doesn't affect it any, okay? We're not adding 1, we're multiplying it by 1, which has no effect. So you just have to consider 1/3 raised to the x power. All right, so here we go. We're going to take -3, or 1/3 raised to the -1/3, or -3 power. So here we go. 1/3 raised to the -3 power. Now that's 1 to the -3 divided by 3 to the -3. Now, both shift, okay? So the 1 to the -3 wants to shift down low, and this one wants to shift above. All right, and so you get 3 to the 3rd divided by 1 to the 3rd, which is just 27. So believe it or not, this is just a whole number. All right? It basically reciprocates the fraction and takes it to the power. It flips it or reciprocates it, or you can say inverts the fraction and raises it to the power of 3. All right, let's do it again. So let's take 1/3 raised to the -2 power. Well, it's 1 to the -2 divided by 3 to the -2. Both switch, or switch sides. They switch. So you get 3 squared divided by 1 squared, which is 1, or 9. Okay, it's a whole number. 1/3 raised to the -1 power gives you 1 to the -1 divided by 3 to the -1. Both switch, and you get 3. 1/3 to the 0 power is just 1. Ooh, look at that. That's a y-intercept, so we already know what that is. So that's cool. You raise 1/3 to the first power, you just get 1/3. 1/3 squared gives you 1 squared divided by 3 squared, which is 1/9. Now we get some fractions. Now the numbers are getting small. And take a look at the pattern here. The y values go from 27 to 9 to 3 to 1 to 1/3, 1/9. Everything's decreasing here. And that's the opposite of what we expected, or what we did, or what we had in the growth functions. As x increased in the growth function, so did y. But in the decay or decreasing functions, y gets smaller here as x gets bigger. That's totally different. So we have 1/3 here raised to the 3rd power. 1 to the 3rd divided by 3 to the 3rd. That's 1/27th, even smaller than 1/9. All right, so y is decreasing here. So y is decreasing. That's why we call it a decay function or a decreasing function. Right here, they're getting smaller. So let's go ahead and plot here. We got to go left 3 up 27. So let me make these numbers bigger so you can see things here. Let's see if I might even have to change the scale. 2, 4, 6, 8, 10. Oh boy, I should have changed my graphs. Well, we're gonna plot -2, 9 then. So 10 here, 12, 14, 16. I could have changed to 4s. Do I want to do that? 4, 8, well, let's see. 4, 8, 12, 16, 20, 24, 28. I could do that. Nah, I'll just plot everything but the first point. So 2, just make it easy on you guys. So 2, 4, 6, 8, 10, 12. That should be good enough. All right, so we're not going to plot negative 3 comma 27. So negative 2 comma, I'll put that in red. So negative 2 comma 9 is left 2. There's negative 2 comma 9 right here. There's negative 2 comma 9. Negative 1 comma 3, left 1 up 3. There's negative 1 comma 3. 0 comma 1 is right here. There's your y-intercept right there. Y-intercept. And 1 comma 1/3. Okay, right 1 up a teeny bit. Now you got to remember when you have to divide this little unit into thirds, and you go up a third. There you go. There it is right there. See, if this is 1 unit high, then a third is just a teeny bit. It's 1/3 of it, 1 part out of 3. 2 comma 1/9, right 2, there's 2, and this is 4, and this is 6. So right 2 up a teeny bit. Right 3 up even smaller bit. So right 3 up a smaller bit, right above the axis here. So when you graph this function, it's decreasing, and the y values are getting smaller and smaller, but never equal to 0. All right, it's decreasing. Look at the arrows here. It's decreasing. These values are going down as x is getting bigger here. That's a relationship. All right, it's a decreasing function. We have a horizontal asymptote here. These y values will never be 0. All right, we have a horizontal asymptote at y equals 0. I'll show you that on a better graph here in a minute. HA for horizontal asymptote in my notes. Y equals 0 here. Because it doesn't touch the x-axis and it will never cross the x-axis, there are no x-intercepts here. Does not cross, okay, x-axis, and because of that, there are no x-intercepts. Now, the range here, all these y values, they're all positive. All y values, okay, are positive, okay, and, all right, greater than 0. And that's why the range y is greater than 0. Remember, range is a set of y values, domain is a set of x values. Got to keep that in mind. All right, now let's take a look at another graph here. Let me plot some functions. Plot this function for you so you can see things better. I used it for another function, so let me change this. Give me a second here. So what we're going to do is we're going to change this to 1/3. There we go. And we're going to raise it to the x power. So I got to go to the power of x there. And we're going to make the asymptote. The asymptote should be 0. So I'm going to put a 0 here. Let's graph. Let's take a look at this guy. Now check this out. This is totally different than our growth functions. Our growth functions didn't behave like this. Here, as x gets bigger to the right, the function decreases sharply, and then it flattens out here past the y-axis there and approaches the x-axis. Look at this. The computer can't even show you how close it is. Let me zoom in so you can see things a little bit better here. Okay, let me back out. There we go. So when you're on the function, you're right here, and you're going to the right, it flattens out, and it becomes asymptotic to the x-axis here, to y equals 0. Now the y values, look at this, 0.04, they're small. You can tell it's very close to the axis here. And look at this, 0.0058, that's really, really close to the axis. They'll never go below it. They'll never, ever, ever be 0, and they'll never go below this axis, and that's why the range is all y values greater than 0, because guess what? They're above the axis. Think real simple. All right, and that's what this function looks like and how it behaves. So let's go ahead and record that. Let's actually, we did record that. Let's take a look at what happens when you add 2. What happens here? How does this affect the graph? So how does +2 affect the parent? And when I say the parent, I'm talking about just 1/3 to the x power. 1/3 raised to the x power. That's the big question. And you probably already know what it is because in the previous two lessons, we know what the +1 did and the +2 and the -2 did. So be thinking about that. All right. So let's go ahead and work this out. It requires a little bit more arithmetic here, so get your paper ready. We're going to put in a domain of -3 to +3 here, and we're going to work these out. So 0, 1, 2, 3. Okay, now remember, you could take 1/3 to anything you want. 0, any negative number is appropriate, and 0, and any positive number. So that's why the domain for these exponentials is always all reals. The range is not, however, so we determine that later. All right, so here we go. We're going to take 1/3 to raise it to the -3 power. All right, and then we're going to add 2. All right, so this becomes 1 divided by 3 to the -3 plus 2. That's 3 to the third plus 2, or 27 plus 2, which is obviously 29. So we're going to put a 29 there. Look at that. First, in the parent function, it was -3, 27. Now it's -3, 29. So the big question is, how does these two values compare? Okay, obviously, 29 is 2 bigger than 27, and that's what this +2 does, is it makes the y values 2 units bigger, and that's why this has a vertical shift up. You can already tell that vertical shift, okay, up 2 units. I just answered the question even before I started my graphing because I can compare the offspring, okay, to the parent, and I can see that, well, the y value is 29 and it was 27. It's 2 units up. 29 is 2 units bigger. It's pretty obvious. And we're going to see that in the table through all the y values. All right, so here we go. We're going to take 1/3, raise it to the -2 power, and add 2. Well, that's 1 to the -2 divided by 3 to the -2. These both switch. They switch places because of the negative exponents. You get 3 squared plus 2, or 9 plus 2, or, excuse me, I gave you the answer right there. So there we go, at 9 plus 2, and that's 11, all right? It was 9, -2, 9, now it's -2, 11, and that's because the y values are 2 units bigger, all right? It's pretty obvious. All right, let's try it again. So 1/3 raised to the -1 plus 2. That's 1 divided by, or 1 to the -1 divided by 3 to the -1 plus 2. 3 plus 2 is 5, and so let's put a 5 there. When you take 1/3 to the 0 power, you get 1 plus 2 is 3. 1/3 to the first power is 1/3 plus 2 is 2 1/3. 2, 1/3 to the second power. Let's get some scratch paper here. Check this out. So 1/3 raised to the second power. Wait a minute. Let me verify my numbers here. Found my lesson here. There we go. We want to take, to the second power. That's 1/3 times 1/3, or 1/9 plus 2, 2 and 1/9. 1/3 to the third power, and that's 1 to the third, which is 1, 3 to the third, which is 27. That's 1/27 plus 2, or 2 and 1/27. Notice that all of these y values here in the parent are 2 units bigger. Okay, the y-intercept here on the parent was 0, 1. Now the y-intercept, all right, is 0, 3 because it's 2 units higher. It's pretty obvious. So let's go. Everything's been raised 2 units, including the horizontal asymptote. So let's plot. So left 3 up 29. It's going to be kind of hard to plot, so I'm not going to plot that one. I'm going to plot -2, 11. So there's 2, 4, 6, 8, 10, 12. That's good enough. That's -2, -4, 2, 4, 6. Ready to go. So here we go. So -2, 11. Left 2 up 11. Right there. -2, 11. And -1, 5. -1, 5. And 0, 3. 1, 2 and a third. So 1, 2 and a third is just a little bit above 2. 2 and a little bit. Right 2 up 2 and a little bit. Right 2 up 2 and a little bit. Right, 3 up 2 and a little bit. All right. See, these are all above 2. And that's why there's a horizontal asymptote right here. Y equals 2 now. Call that HA for horizontal asymptote. We'll see that. When you graph your function here, let's go ahead and do that. Let's guide the function right through these points. It's decreasing, 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 and flattens out. And these Y values, they're decreasing. I'll go down arrow here. And they're getting smaller and smaller and smaller, and they're all approaching 2. Okay? Approaching. All right, approaching 2, and that's why we have this horizontal asymptote, is because it approaches 2, it flattens out. Also notice there's no x-intercept. Why? Because it doesn't cross the x-axis. There is, however, a y-intercept. That's 0, 3. That's pretty obvious. And the range here, all these y values, 29, 11. This is the range now. This is the domain. They're all above 2. Look at it. They're above the horizontal asymptote. All these y values are above 2. Okay? Above 2, and that's why the range is y greater than 2. See, it's not that hard. You just have to train your mind how to think about it. It's not that hard. Okay, let's handle the next 2 offspring. All right, here, what kind of effect does this have? And you know what, right here, I'm going to change this function here. I'm going to change that right there because that's a different type of translation. I'm going to go, this is a -3, this is going to be a -1. Let me see, I did a +2, yeah. Okay, and that's what I'm going to do. I'm going to say, how does it change when we subtract 3, and how does it change when you subtract 1? There we go. So make sure you fix this in your notes. So just change the exponent to x, and then subtract 1 from the function. So it kind of looks like the third offspring, or the second offspring. So let's put a domain in. So we have -3 to 3. And let's go for it. So again, you take 1/3 raised to the -3 power minus 3. All right, this becomes 27 again. So 1 to the -3 divided by 3 to the -3. Both switch, you get 3 to the third minus 3. That's 27 minus 3, and that's 24. Take a piece of paper out, like I said, and do all the arithmetic on the side, because there is a lot of arithmetic. That's only the first value, so I'm not going to even have enough room. And then you have to understand this negative exponent here reciprocates the fraction. So when I see 1/3 raised to the -2 minus 3 here, I reciprocate this in my mind with a negative. I get 3, and then square it, and that's 9. 9 minus 3 is 6. 1/3 raised to the -1 reciprocates the fraction. I get 3 minus 3, and that's 0. Next one, 0 power. Well, that's 1. 1 minus 3 is -2. There's a y-intercept. 0, -2. When you substitute 1 in there, we get 1 minus 3, which is, excuse me, that's wrong. 1/3. 1/3 minus 3, that's a -2 and 2/3. So -2 and 2/3. Substitute 2 up here. All these go up here. You get 1/3 times 1/3, or 1/9 minus 3, and that's -2 and 8/9. So -2 and 8/9. And then 3, that's 1/27 minus 3, and that's -2 and 26/27. So what you want to do is you want to plot these guys. 2, 4, 6, 8, 10, 12, 14, 16, 18. So we're going to plot -2, 6 down, okay? And let's see, this is -2, this is -4, 2, and 4, and this is the x-axis. Here we go. So -2, 6. So left 2 up 6, that's easy. So -2, 6. -1, 0. Oh, guess what? That is an x-intercept. Okay, so -1, 0. It's right there. That's on the x-axis, so it's obviously an x-intercept. 0, 2. Excuse me, 0, -2. That's a y-intercept. 1, -2 and 2/3. So not quite -3 yet. So 1 comma negative 2 and 2/3. Right about there. So right 2 down almost 3. Right 2 down almost 3. Right 3 down almost 3. Right about there. It's flattening out. All these values you get approaching, all of these, the y values, okay, are approaching but not going to be equal to negative 3. And that's why we have a horizontal asymptote. So I'm going to draw one at negative 3. So y equals negative 3 is my horizontal asymptote in this case, because everything's been dropped down 3. Okay, you got to remember, this right here is a downshift. So downshift 3 units. All right, down because it's negative. Okay, down a minus 3. So let's graph this function here. It's a decreasing or decay function now. Ooh, and it flattens out and approaches the horizontal asymptote. Y values are decreasing, but all these values, they're all bigger than negative 3 because they lie above it. So my range is y greater than negative 3. As you already know about the domain, it's a set of all reals for all exponential functions. Okay, because you can take a base to any power you want. All right, but all these y values, 24, 6, 0, negative 2, and all these fractions right here are all above negative 3, so they're all greater than negative 3. All right, and the last one we need to do is this one here. So let's set up a domain of negative 3 to 3. All right, and we'll do the arithmetic on the side. We should expect something similar like this, but instead of down 3, we'll probably down 1. Okay, downshift of 1. That's what we expect from prior experience, right? So it's a downshift 1 unit down. Downshift 1 unit. If this is a downshift of 3 units, and I'm talking about this minus 3 here, then I expect the minus 1 to be a downshift of 1 unit. I mean, use your common sense. All right, so here we go. Negative or 1/3 raised to, I'll do it again, what the heck. So 1/3 raised to the negative 3 minus 1, okay? And that's going to be 3 to the 3rd minus 1, or 27 minus 1, or 26. There we go, 26, there we go. So put that in. 3 to 1/3 to the negative 2 minus 1, that's 3 squared minus 1. 9 minus 1 is 8, so that's 8. 1/3 raised to the negative 1 minus 1 is 3 minus 1, or 2. 1/3 to the 0 power minus 1 is 1 minus 1, or 0. 0 there, so 0, 0. That's not only a y-intercept, but it's an x-intercept because it's on both axes. 1. 1/3 to the first power is 1/3 minus 1 is negative 2/3. So negative 2/3 here. 1/3 raised to the second power minus 1 is 1/9 minus 1, or negative 8/9. So negative 8/9. And 3, oops, not 3, but 1/3. So 1/3 raised to the second power, no, third power, is 1/27. 1/27 minus 1, negative 26/27. So negative 26/27. Okay, now you go for it and you start plotting. So left 3, let me see. Let me scale the axis. So 2, 4, 6, 8, 10, 12, 14, 16. 2, 4, 6, negative 2, negative 4, negative 6. All right, here we go. So we've got left 2 up 8. So left 2 up 8. There's the first one. Left 2, left 1 up 2. There's this one here. So negative 2 comma 8 here. Negative 1 comma 2 here. 0, 0 here. 1 comma negative 2/3 is right 1 down 2/3. Down 2/3. Right 2 down almost 1. All right. Right 3 down almost 1. So it's not down at -1, okay? It's down almost -1 because these are all, they're approaching -1. All of these y values are approaching -1, but they never reach it, never attain it. And that's why this is an asymptotic function right now. Oops, missed it. Let's try it again. There we go. And I have a horizontal asymptote right here at -1. So y equals -1. Y equals -1 is my horizontal asymptote. Now the function is decreasing, of course. All these y values are getting smaller, but they're all above -1. So that's why the range is greater than -1. The domain is still all reals because all exponentials have that domain. But this relationship here between x and y is different as x increases, okay? Okay, it goes up. Okay, from 0 to 1 to 2 to 3 to 4 to 5 to 6. All these y values are decreasing from 24 to 6 to 0 to -2. They're all decreasing. Y is decreasing. This is a characteristic of all decreasing functions, or what are called decay functions. Okay, it goes down. Okay, and we say exponentially, it really goes down fast. All right. Now remember, this was a video. Go ahead and watch it again if you like. Watch any portion of it and get good at this arithmetic here. As you can tell, we do it all by hand, and that's what we expect when we assess you guys, is for you to be able to handle the arithmetic and do it all by hand. All right, and I'll see you in my next video. This is Mr. Ainsworth signing off.